Good morning, ladies and gentlemen. Today we're going to be talking to you about acrylic acid from the oxidation of propylene. My name is Liliana Vela.
My name is Thomas Castaño.
My name is Yatsiri Martinez.
And so acrylic acid is a widely used intermediate for textiles, polymers, and many other chemicals. Pretty much an intermediate for acrylate esters, and these are used to manufacture adhesives, plastic additives, coatings, paints, and again textiles. It is very hazardous to human health, so it pretty much should be dealt with a lot of precautions in a local exhaust ventilation, try to keep all the areas clean. Since it's very reactive, it must be cooled down pretty quickly right after the reaction, and it must be stored in vessels between 50 and 70 degrees Fahrenheit. Since the polymerization of the acrylic acid is very violent, some other hot vapor and polymer can be released, and this could cause a auto ignition. So it must be dealt with a lot of precautions, and it's valued at $1.90. And again, it's used as it's produced by the oxidation of polymer.
The most widely accepted process for making acrylic acid is the vapor phase oxidation of propylene. In this arrangement, propylene is oxidized to acrolein, and then acrolein is oxidized to acrylic acid. Okay, these are some possible reactions that might occur during the process. And acetic acid is not only used for the production of vinegar, it can be used in the production of plastic soft drinks, bottles, as well as many synthetic fibers and fabrics.
Here we can see a block flow diagram. Propylene and oxygen enters to the reactor section with the steam as catalyst. Then the product goes to a separator and absorber section where where wastewater and off gas is separated from acetic acid and acrylic acid. Then goes to a distillation column to get purified, and then the main products, the acrylic acid and acetic acid.
So for our process flow diagram, first off you see on the right hand side is what we start off with as our ingredients for our product. And so it goes into our pipeline with air, low pressure steam, and propylene, where it's oxidized in a two-stage reactor. First it goes, like Yatsiri said, to acrolein, and then it's oxidized again for our final product. It goes into a phase separator, and so from the phase separator, for further separation, it goes into an absorber. So from the phase separator and absorber, they're both fed into our extraction tower. And the extraction tower separates further from our waste products such as the carbon dioxide and the water, which goes to our wastewater treatment. And then when we're left with our products, it's sent into our distillation tower. And from our distillation tower, it's separated into acetic acid and acrylic acid, which is our final products. So major equipment, so is just our blowers, our coolers, our pumps, our absorbers, everything like that. I just explained.
Okay. We have the compound boilings and melting points. The boiling point for acrylic acid is 285.8 Fahrenheit, and for the melting point it's 57 Fahrenheit. The propylene in a chemical grade, the boiling point is negative 53.68 Fahrenheit, and the melting point is negative 301.4 Fahrenheit. And the acetic acid is 244.6 Fahrenheit, and the melting point is 61.9. And for the oxygen, we have negative 297.3 Fahrenheit, and for the melting point, it's negative 361.8 Fahrenheit.
Here's the cost for each product and each reactant. The acrylic acid is $1.92 per kilogram, propylene is 0.47 cents, 147 dollar per kilogram. Acetic acid, 0.94 cents, and oxygen, $2.
And so, yep, that's our thing. So thank you very much.